What's up, everybody, and welcome to the Hydraulic Engineering Tutorial YouTube channel. Today we show experiment number 9 to determine CC, coefficient of contraction, CV, coefficient of velocity, and CD, coefficient of discharge, for flow through a circular round orifice. Apparatus. Orifice apparatus comprises the following: 1. Supply tank provided with A. Circular orifice, B. Water inlet pipe, C. Scale and sliding apparatus, and D. Meter rod. 2nd, measuring tank. 3rd, stopwatch. 4th, micrometer contraction gauge. 5th, stand for mounting the supply tank. Brief theory. It has been observed that when a jet of water leaves an orifice, it gets contracted. The maximum contraction takes place at a section slightly on the downstream side of the orifice, where the jet is more or less horizontal. Such a section is known as vena-contracta. The ratio of area of the jet at vena-contracta to the area of the orifice is known as coefficient of contraction, CC. The ratio of actual velocity of the jet at vena-contracta to the theoretical velocity is known as coefficient of velocity, CV. The ratio of actual discharge to the theoretical discharge is known as coefficient of discharge, CD. Procedure. 1. Fill the supply tank with water and allow it flow through the orifice. 2. Maintain a constant head of water in the supply tank by adjusting the supply of water. 3rd. Measure the diameter of the jet at vena-contracta, DC, with the help of a micrometer contraction gauge. Note down the initial readings of the scales, horizontal and vertical. 5. Slide the vertical scale on the horizontal scale through a reasonable distance and adjust its vertical scale so that point of the hook just touches the center line of the jet of water. 6. Measure the coordinates of the point, say P, in the jet at this position. 7. Note down the time taken for rise of water through a certain height in the measuring tank. 8. Repeat the experiment for different constant heads. Precautions. 1. In each reading head must remain constant. 2. The orifice should be completely opened. 3. The position of vena-contracta should be found out accurately. 4th. Note down all the readings carefully. Don't forget to like this video and subscribe to the channel for more hydraulic engineering contents. Thanks for watching, and I'll see you in the next video.